Welcome to tutorial number 177, the second tutorial in SolidWorks Mold Tools. In this tutorial, we will talk about the first command in the analysis section of Mold Tools draft analysis. For that reason, we will make this plastic mobile cover. So we will apply the draft analysis on that plastic part. And we will show you how we made this in this tutorial. And also during the design process, we will have some faces with a draft and other faces without a draft, or we can notice that in the draft analysis process. And then when we are done with the part, we will apply some draft analysis to that part and see if it requires some drafts or not. And that is the first step for preparing the plastic part for injection molding and creating a mold. And we will see the colors and explain them and read the draft from the part and see if there is a need to add any draft to the part. Now we will start making a front cover of a simple mobile phone. Start a new part. Go to the top plane, start a sketch and pick a center point rectangle and give it dimension of 43.5 and second side 118.5. Add a fillet of 18.5 to the upper corners and 12.5 to the lower corners. Now we'll make another sketch or another profile for the top. Select 3-point arc and here and give it a dimension of 50 radius and the point from here to here 26. Make this point and this point horizontal. So now we will extrude the first profile. Go to feature, extrude and select the outside profile, extrude it to 5 millimeter and add a draft of 5 degrees. So that is an important. Click OK and now show the sketch. So select the sketch, go to extrude, selected contour, select that contour and it have to be 5 plus 3.5 and the draft as well 5 degrees merge results. Hide the sketch. And now select the right plane, start a sketch to make a cut on the upper side. Select 3-point arc and make an arc from the first edge to the second edge with a radius of 25 and the distance between this point and the upper face 5 millimeter and make the distance between this point to the corner 15 millimeter. Go to extrude cut. You see the arrow of the cut is upward. Make it through all both. Click OK. We will add some fillets. Go to the fillet, first fillet is over there, and make it 20. Click OK and make another fillet with radius of 7.5 and select this edge. OK, and the last fillet for the upper face is 3.5. Select that edge, click OK, click OK. Now let's shell the cover with a thickness of 1 millimeter. Click OK. And now we will make a cut for the screen, the mic, the speaker, and the buttons. Go to this face, start a sketch, normal tool, and here make an offset of 1 millimeter. Reverse, click OK. So this is the first cut for the screen, and here we will make a cut for the speaker. Let's make a reference circle over there for construction and give it a dimension of 7.5 and dimension from this point to the upper edge also 7.5, 9 millimeter, and the center of the circle to this point vertical. So this is the reference circle for the speaker holder, and now we'll make another circle for construction for the cuts. Make it a dimension of 7.5 divided by 2, and let's make the cut circle 1 millimeter. This circle is equal to this circular pattern. Direction is this point. Click OK. Here we can make the hole a bit tighter. We can make 3.25 and make a relation over there and add a dimension to fully define the circles. And here in the bottom we will make a slot for the mic. Draw a slot with the dimension of 3.5, the radius of 0.5, and the distance between this point and the down edge 9 millimeter. Give a relation from this point and the origin of vertical. Here we can make it a little bit smaller, 5 millimeter. So now we can make a cut and make the buttons in another cut. Now we will make holes for the buttons. Start a sketch on this face, normal to, and draw an ellipse. Give it a dimension of 7 millimeter, for the vertical distance 5.25, and the horizontal distance 7.25, and make a distance from this point and the origin to be 11 millimeter. Now let's add some relation to fully define the sketch. Select these 3 points, make horizontal, and this point vertical, and add 2 more dimension from this point to this point, the lowest edge of 18.25 millimeter. Here we'll draw a center line for reference reasons. And now make a linear pattern with that ellipse. Entities to pattern this ellipse. On the x-axis, make it 11, and 3 reverse the directions. So you have the second ellipse is central in the middle, and we need 4 on the y-axis. And make a distance of 8 or 9 millimeters. Click OK. And here we'll draw the main buttons. And here make this line, this point coincident, and give a dimension of 10.5 this, and here give it 5.5. Let's fix this ellipse, and here the distance 5.5, and this line 8.25, and add a fillet for the corner of 2.5. Go to mirror, select these entities, this line, click OK. You can add a fixed relation for each ellipse or fully define sketch, and make a cut through all. Click OK. Now we will make housing for the mic and speaker holes. So if you show the sketch of the speaker holes, and here for the, and let's add another circle for the mic, edit sketch, normal to, and let's make the distance a little bit bigger, 7.5, and add a circle, make this circle with this line tangent, and make that circle for construction. A sketch on that face, normal to, select this line, convert entities, As well, select that line, convert entities. Go to features, extrude, select here, then feature of a thickness 0.75 inside the circle. And extrude it up to body, select that body, and here make an offset of 2.5 in the other direction. Click OK. Start a sketch on that face, normal to, and draw a circle over there, the dimension of 3.75, and distance between this point and the origin 11 millimeter, and the vertical distance 50 millimeter. Make a center line to mirror this circle on the other side. Select mirror, select this circle, mirror about center line. As well, we can mirror them on the left side. Make again another center line, mirror, select both circles, mirror about this center line. Click OK. Now extrude out the body. And we will add to these screw cylinders extra fits so it fits better on the second side. This process could be saved if we make the circles in the previous process when creating the screw cylinders. Select this face, click offset 0.3 reverse direction, make it inside, click OK. And for the rest as well. Go to feature, extrude 1 millimeter. Click OK. Now we will make the holes for the screws. Go to hole wizard, select hole, and the diameter is 2 millimeter, and the distance here make it 5.25. Position, select each cylinder of them. Let's check the hole. They are not. Okay, here we need to decrease the hole, make it 4. That looks okay. Then click OK. And here we have the holes. And one final touch to add a fillet for the edges. Make a fillet 0.25. Select this face. This face. This face. Here is our mobile cover ready. First thing I would like to mention is the top plane. If we notice over there, the top plane is our reference in creating this part. So I will show that plane. And now go to Mold Tools, select Draft Analysis. So the first option over there is the analysis parameters, which means that we need the reference for this injected molded part, which represent the direction of pulling and injecting. For example, in this case, we can consider the top plane is the reference because the pulling will be upward. So we select the top plane, and here the angle represent the draft angle. So this angle is probably high. For this I will make it 1, but for now, if you notice the part, we have green on the top side, as we discussed it in the previous tutorial, that represent positive draft, and the yellow faces, these are parts require drafts, and the negative, so far it is in the bottom side, that represent a negative draft. It is okay so far, it is in the bottom side because this side will be dragged outside. So as you remember, in the design process we added a draft for that face in the upper side, and we didn't apply any draft when we created the screw cylinders. So that you can see that in the draft analysis process. So the draft analysis purpose is to check for draft and which part you draft. So that is the reason we didn't add a draft, to show you that it can be shown over there. So, and if you hover over the face, you will see the drag or the draft angle is 0 degrees, and if you hover over this, the draft angle 5 degrees. As you remember, when we started to make this part, we extruded with a draft of 5 degrees. So close this for now and go to the part, and here we added a draft of 5 degrees. So let's just remove the draft, click OK, and check the draft analysis, check the top plane, and here the side, outside side without any draft, you will notice it is in a yellow part. So this is one thing to think about, is while designing a plastic part, to add a draft during the process. That may save some time. So exit the draft analysis and fix the part again at the draft of 5 degrees. Now go back to draft analysis, select the analysis parameter, we set the top plane, and here is the draft angle. This draft angle is for comparing reason. For example, we wish to have 5 degree draft angle, for example, for the outside side, and if you click OK, that will show you everything is in green, and click again. Let's say that we needed 10 degree for our product, so select the parameter, and here you will see that this side will require a draft, but for our case we already applied the draft for the outside face, and we don't need to compare it, and just need to compare the draft of the inside cylinders, and we wish to have between 0.5 to 1 degree draft angle. So let's make it 1 degree. So you'll see that the top face is okay, and we need only to fix the outside face of these cylinders. And if you go to adjust triad, if this is if you would like to change the angle of the reference plane. For example, we said the plane representing the direction of pull. So if we adjust, and let's say that part will be injected in with an angle, and you will notice there are some troubles with some faces, but that case is not logical, and just exit to return to normal and or Ctrl Z and start again. And here we set 1 degree, and let's say for the direction of pull we pick it the right plane. You will see there is something wrong and everything needs to be changed, and it is clear that the direction is wrong. Otherwise, that is the correct direction of pull, and then this part will require a lot of work. For example, you need draft in each of these faces. So return to top plane, 1 degree, and face classification. So the positive draft, we have 32. The faces require draft in yellow, 59, and the negative are 49. The negative ones, they are okay. So far they are in the bottom side. Straddle face. This face is kind of in between in some meeting points. And here the positive steep over there. So these faces are in green. It is somehow okay. They are laying in between the positive draft and the required draft face. So the area in between, it can be a steep face. And for the bottom steep, it will be in dark blue. And let's say that we need to apply a draft angle for these outside cylinders, and then start the draft analysis once again. So for this, for example, the bottom holes, we can apply a draft, but it is a thin layer. It might not be that big problem for injection molding, but the cylinders over there we need to try to fix or add some draft. And inside cylinder, since it is designed for a screw, logically it doesn't need any draft. So exit and see how we can apply a draft for these faces. So you have one choice is to go to draft over there in another way by going to the solid feature over there, and when we extruded this part, you could add an angle of 1.5 and make it outward. Now go to draft analysis again, and the reference plane is this plane, and here we set 0.5, so we get the red over there. So as we said, the red in the bottom side is okay, and we can add one more draft for that face. Select add draft 0.5, click OK, and check the draft analysis once again, and here we get a red color. So we need only two faces over there, this face and this face. Click OK, select this edit feature and add draft of 0.5. So we got a green, that means in the bottom side, that means this is a wrong direction of ball. So edit again, make it outward, click OK. So now we have the bottom side is ready, and we have the balls, we have the draft applied for the required faces, and on the top side. And if you wish to add a draft as well for that part, so that can be done during the cut by adding a draft and running the draft analysis once again. So one last conclusion, this tutorial, that the draft analysis is a very good way to check for the draft. If someone needs to add a draft, it is a good practice to add a draft during the design process. That would save some time.